So in this video, let us see the lead code, platform program number 766, that is Toeplitz matrix, which is from easy level. So first let us see the problem statement. Afterwards, let us see the implementation. Okay. So here M by N matrix is given, so that is a rectangular matrix. Should return true if the matrix is Toeplitz, so otherwise we should return false. Okay. And so information is given here. So regarding Toeplitz, so that is a matrix is Toeplitz if every diagonal from top left to bottom right has the same elements. Okay, so that is so observe here. So from top left. Okay, from top left to bottom right. Okay, let us take so this. So observe everyone. So this matrix here. So 5 and 5 values, let us take so these into MS Word. So it's 1 2 3 4 and 5 1 2 3, next 9 5 1 2. So here so you can observe from top left so to bottom right you can find the same thing. So here 5 and 5s are matching. So here so these ones are matching. Next here so twos are matching from so top left to bottom right. So here also threes are matching. Okay. So here so you can notice one thing here. We should check only these position values. It's not required to check so the uh, top right so corner value, that is 4. Okay, so means and next of all, so the bottom left corner value 9 is also not required to check. So means what position values we need to check here. So we need to take down this 0 1, it's 0 2. Next 1 0 1 1 1 2 and 1 3. Next finally 2 1 2 2 and so 2 3. That's it. 1 0 position we should compare with so 22 1 position here. So first let us start from the beginning. Okay, so that is 0 0 with so 1 1. Next 1 1 with 2 2. Okay, next 0 1 with 1 2 and 0 2 with 1 3. Next let us move on to the next position. So here that is 1 0 position, so we should make comparison with 2 1. Next 1 2 position we should compare with 2 3. Okay, that's it. So here so row and column values we are getting into I and j variables, so you already know this in 2D matrix. So I and j variable values we need to compare with the I plus 1 and j plus 1 position values. Clearly you can understood this. You should compare with I plus 1 and next of also the j plus 1. Okay. So 1 1 position we should compare with 2 2. 0 1 position we should compare with 1 2. 0 2 position we should compare with 1 3. 1 0 with the 2 1 and next of all 1 2 with the 2 3. Means clearly you can understand one thing. IJ positions we should compare with the I plus 1 and j plus 1 position values. Okay. And so here only we need to focus on generating so these positions, so the left side position, IJ positions, that's it. Okay. So with the help of ij positions, we can make comparison. So with the help of I and j variables, we can make comparison of I plus 1 and j plus 1. Okay. If you carefully observe, so here row subscript values, you can understand one thing. So you can notice only so zeros and ones only. That's it. Okay. So means it's not required to generate so this last row so subscript values here. Okay. So for it's not required to generate so this last row with the help of so the previous row so positions we are going to make comparisons for the next row positions means rows loop we should run up to the so size minus 2 position. Okay, it's not required to run up to size minus 1 position. And if you observe so the next second subscript values you can so sorry here first, second subscript values also if you observe, so you can notice one thing here. So that is, so you can observe only zeros, ones, and twos. That's it. Okay. So means it's not required to run up to the so the last column. Okay. With the help of so these positions 0 2 we are going to make comparison of 1 3. With the help of 1 2 we are going to make comparison of 2 3. So simply, what do you understand? So from this here is we should run the rows loop and columns loop up to the size minus 2 positions. Okay, row size minus 2 position and column size 2 position. So you already know this concept also while working with the adjacent position values. You should not so run loops up to the ending. Okay, so if you run loops up to the ending, we'll get the index errors. Okay, same thing here we are going to apply now. I hope so each and everyone understood the problem statement now. So how to design it. What if the matrix is stored on the disk and memory is limited such that you can only load at most one row of the matrix into the memory at once? If the matrix is so large that you can load up to a partial row into the memory at once. So check whether here int is given, check whether each value is equal to the value of its top left neighbor or not. Okay. And after completion of this, so try this valid word square, which is from subscription. Okay. If you have subscription, you can try it. Okay. So fine, let us complete this one now. So what, first of all, let us take row size and column size here. So length of matrix and column size is equals to length of matrix of 0 and for I in range of r minus 1 and next for j in range of c minus 1. So here, if we found any one of the ij position value not matching with the I plus 1 and j plus 1 position, there itself you can stop and return false. It's not required to check the remaining position values, right? Okay. So reverse logic so makes you to work the program faster. Okay. So if it matrix is not Toeplitz, so that is if matrix of ij position values if not matching with the matrix of so I plus 1 and next of also the j plus 1. So stop there itself and it's return false. For suppose, okay, so if all ij position values are matches with the so I plus 1 and j plus 1 positions, then in that scenario, so control comes outside of both the loops, right? Okay, nowhere else. So this condition becomes true means. So finally, both loops ends and control comes outside. In that scenario, we need to return so that true. Okay. So means it's a Toeplitz. All ij and I plus 1, j plus 1 position values are matching. Okay. So this is the way of designing so the solution for Toeplitz matrix here. So let us check whether it works or not now. Yes, base case accepted. Next, let us submit. Yeah, it's working fine. So that is a Toeplitz matrix program. So I hope so each and everyone understood this. Okay. So let us meet in the so next video. Thank you. Thank you, everyone.